So this video is going to show you how to find an angle that is inside of a circle, not at the center, but just inside. So if you look at number 1, it says, what is the degree measure of angle CEA? You can tell that the vertex of that angle is inside of the center. So if you look at the theorem up above, it says this angle is equal to half of the sum means add, half of the sum of the intercepted arcs. So in this case, what we're going to do is add together the intercepted arcs, which are the arcs in front and behind, and take half of it. So to get the angle, I like to write it out as an equation. You'll see once we get to number 3 why I do this. So the angle is half of the sum of the 87 degrees and the 35 degrees, those intercepted arcs. So using PEMDAS, we have to add together the 87 and 35 because it has parentheses, and you get 122. There we go. And half of 122 is 61 degrees. Number 2, same kind of thing here. We want to find the degree measure of angle ABC. It's inside of the circle, so we are going to add together the intercepted arcs, the arcs in front and behind, and then take half. So the angle is half of the sum of the 36 and the 20. It doesn't matter which one you write first because either way they're going to add up to 56. Okay, so we have half of 56, which is 28 degrees. Okay, so number 3 is going to be a backwards problem. So what's going to end up happening here is we have the arc AB is 64 degrees and angle AEB is 52. You can see that we have that interior angle. What is the measure of arc CD? Well, I don't know that arc, so I'm going to write it as an X. Now, I solved this as an equation. Remember, the angle is half of the sum of the arcs. So basically, I take this rule and I just plug in what we have. So we know the angle is 52. And it is equal to half of the sum of the intercepted arcs. So that would be the arc in front, 64, and behind, which is X. Doesn't matter which one you write first. I'll just put the 64 first. Next we want to solve for X. So what I do next is I get rid of this 1/2. I get rid of the fraction by multiplying both sides by the reciprocal. The reciprocal of 1/2 is 2. So I'm going to multiply both sides by 2. 2 times 52 is 104. And it equals, now over here, half of 2 is 1, so that just cancels out, and you're left with what's inside of the parentheses. Then to solve for X, you're just going to subtract 64 from both sides, and you get that arc X to be 40. And I'm going to show you one more problem here, number 7, which involves ratios. So the measure of, we have arc AC is represented by 4. Now what you want to do is put an X with each number because 4 times some number will give us arc AC. And then 2 times some number will give us arc CB. BD is the 6, so this would be the 6X. And DA is the last number, so arc DA would be represented by 8X. Now first up, we need to find X. So all of these ratios, if you can see, it forms the full circle. So what we're going to do is add them all together, and it equals full circle, which is 360 degrees. So if we combine like terms, we will have 20x equals 360. Divide both sides by 20, and you get x equals 18. So I'm just going to take that 18 and plug it in. So 8 times 18, we get this arc is 144. 6 times 18, we get 108. 2 times 18 is 36. It's arc BC up here. And then over on the left, 4 times 18 is 72. And the question said to find the measure of angle DEB. Well, DEB is an interior angle. Again, the rule is it's half of the sum of the intercepted arcs, which are the arcs in front and behind. So the angle is half of, the arc in front was 108. Sum is means add, and behind it was the 72. Add those two arcs together, and we get 180. And half of 180 is 90. So that angle is 90 degrees.